All right, looking at your stuff, this is going to be in, your x is going to be in radians, okay? All right, so we're going to start at 0. Then we're going to go pi over 4, pi over 2, 3/4 pi, right? 3 pi over 4, and then pi. And then we've got 5 pi over 4, 3 pi over 2, and then 7 pi over 4, and then 2 pi. All right. Now, what I need for you to do is to take about a minute to get your sign values at these particular radians. Okay, so we'll give you a minute to do that. So I'm curious what you got for the output here. Everything comes from unit circle. Right? Okay. So I needed you to fill in this based off of that. Right? Okay, so what's the first thing? Yeah, 0. What's the next? What's the next value that needs to go, folks? Square root of 2 over what? Okay, good. Where'd that come from? Yeah. You're taking the sign value of the x, and the x happens to be pi over 4, which is, ladies and gentlemen, it's the y value square root of 2 over what? 2, right? Now, pi over 2, 1. 3 pi over 4, square root 2 over 2. How about pi? How about 5 pi over 4? All right. How about 3 pi over 2? Negative 1. All right. What about 7 pi over 4? Negative square root of 2 over 2. How about 2 pi? Okay. Questions? All right. Somebody take square root of 2 over 2 and give it to us as a decimal. Square root of 2 over 2 is what? 0.7? Yeah, go. All right. So square root of 2 over 2 is 0.71. 2 decimal places, right? All right. So the easiest thing to do is say that this is what? 0.5, right? And that this is what? 1. So this would be what? Negative 0.5. And this would be what? Negative 1. Questions? Any questions on that? The really cool thing about having the y-axis not be already labeled for you or scaled for you is this. You can scale it however you need to. Right? So each step is a quarter. All right? So what I need for you to do is go put dots at these ordered pairs. The x-axis contains radians. The y-axis contains values, right, of decimal or integers. So I need you to put dots where things are. Go. All right, so let's see if you've got what I'm getting here. So color 0, 0. There you go. This is pi over 4, and I need to be at a little bit right about in there, right? Pi over 2, I need to be at what? 1. 3 pi over 4, I need to be back at where? The square root 2 over 2. And then at pi, I'm back to who? 0, right? What does that look like right there? A parabola, right? Look at the symmetry. It's pretty cool. And then we go to 5 pi over 4, which is down here. And then at 3 pi over 2, we're at -1. And then, of course, right back here at negative square root 2 over 2. And then back at what? 0. Does your dots look like mine? Say. Yeah? All right, so I'm going to take the, well, I guess I'm going to do this by hand. Because I do it over here, it'd be crazy. All right, so I'm going to do it with green. Just, there you go. Questions? Connect the dots. That's the shape that you should have. Okay. Any questions? Yeah. What does it mean when it goes like what? That shape? It means it's a sine wave. Okay. Oh, it is. Where have you seen this? Say. Where have y'all seen this? No one's seen this shape? Ever? In not good things. In the thing? Okay, let's look at the cosine. So y equals cosine x. So we got x values, we have y values, right? So the x values are 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. All right, so give me the values. What are my y values? 1. What is the square root of 2 over 2, guys? Yep. Okay. All right. 0. Negative square root of 2 over 2. Negative 1. Negative square root of 2 over 2. 0. Square root of 2 over 2, and what? 1. Any questions? Where did you get the y values from? Yeah, but where'd you read them from? Unit circle. Good. All right, so we're going to graph them. So let's go put red dots. So we'll say this is 0. No, I keep doing negative right there. I don't want to do that. Brains on that. 0.5. That's negative 0.5. That's negative 1, and that's 1. So we're going to start up here. We're going to say, okay, right there, and then we're going to go where? Right there. And at power 2, we're at what? 0, and then we're down here, right there, back up here, there, and back at 1, right? Yeah? Okay, good. And when we draw this, I'm going to draw it using my board up here. It's a lot easier than freehanding it on that. So there you go. Why is one side thicker than the other? It's in calligraphy. So therefore, it's going to do a leading and falling edge as far as trailing edge. It's going to get thicker to thinner. All right. Questions? How long does it take for the pattern to repeat? How long does it take for the pattern to repeat? No. Look at your graph. Look at your graph. What is it? 2 pi. Folks, so we say that the period is 2 pi. Okay? How long did it take for the sine wave to repeat? Huh? 2 pi. So we'll go here, the period on this one, for a plane chain sine wave is 2 pi. We look at a cosine, it is what? 2 pi. Right? Okay, now, the period is how long does it take for the shape to repeat? Okay, so when we get into transformations, we're going to be looking at things such as amplitudes. So the amplitude on this is how far does it go up from 0. So what's the amplitude for a basic sine wave? 1, right? From the middle all the way to the top is how many units? 1 unit, right? Now, it's 1 unit from here to here as well as from down here, right? You don't do the overall, how far did it go down, how far did it go up for the amplitude. How far did it go up or how far did it go down, right? And then, so what would be the amplitude for a sine wave? 1. Now, what is the difference between a sine wave and a, well, before I ask that, what I need for you to do for the sine and the cosine is I need you have graphed 1 period to the right. I need you to graph it 1 period to the left, okay? So I need you to get into some negative tangents. Can you do that? Okay, go. Sine and cosine, go ahead and finish the pattern on the left-hand side of the sheet, right? Okay. All right, y'all talking, so you must be done. So let's see. I got here, boom, boom, boom. There. Yeah. So I'm gonna do the other with the black. Okay. So you can have thank you. You can have the sinusoidal wave go beyond as far as to the left and to the right. So don't think it's just moving forward. It's also moving, it's coming from the left as well, right? Okay, so you can have it on negative ratings. Any questions on this one? Now, we've got here, there, here, there, here, there, and then up there, right? So I'll do this in blue. There. Now, does yours look like mine? Okay. Any questions on that? My question is this. What is the relationship between a sine wave and a cosine wave? Okay. You have 2 minutes to answer that. Go. Wolfie said it's the same wave, but just moved over. Is it? By how much? Oh. So who has shifted? Depends on which one you reference first. Okay. But a sine and cosine wave are the same, except cosine is shifted what? Pi over 2, which means it's shifted by how many degrees? 90 degrees. Right? Yeah? It's crazy, ain't it? So, there are I guess it'd be identities, because it'd be another way to write a particular trig function, right? That exists, and I can, we'll visit those as we go through and look at transformations, so you can kind of see, if you see a transformation, what it is there, I hate to say a cousin to it, but who is it really? So you can kind of get a pictorial representation in your mind for what's happening. Okay? So there's a relationship between sine and cosine, right? Cosine is shifted pi over 2, 90 degrees. So we've done sine, we've done cosine, right? What's the one we haven't done yet? Tangent. Oh, tangent. Okay, good. So do you want to, let's see, what inferences can you make now that you got sine and cosine? What inferences could you make for tangent? What do you think its amplitude is going to be? Huh? 1. What do you think its period is going to be? Okay. All right. Well, let's see. Y'all ready? You got a lot of calculation, because tangent is sine over what? which is y over what? X, right? And hopefully, as you've been doing your unit circle and you've had to do calculation, when you've had to find the tangent of something, you basically should have been putting that value on your unit circle that you have, right? So that you have it already calculated. Correct? Now, let me say this and then I'll let you do the tangent. If you missed Friday's quiz or anything, tomorrow is study hall. So I'll turn your name in on the study hall as last resort. You got to take it, okay? So it'll be sitting there in study hall for you, okay? Because after tomorrow, I'm done with that. I'm moving on. I'm not going to revisit it, okay? That's 3 days after you've been out. That's more than what the policy said. So y'all understand that. So if that applies to you, you need to get it done. It'll be set. All right. Figure out tangent. Go. All right. So let's look at it. Here's X, here's Y. Excuse me. 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Any questions about that? Okay, which functional we're doing? Y equals tangent of X. Okay. All right. So, what's the first one? Huh? When we take the tangent of 0, what do we get out, folks? 0. When we take the tangent of pi over 4, what do we get out? Huh? 1. We take the tangent of pi over 2, what do we get? It's what? 5. What about 3 pi over 4? Negative 1. Man. How about pi? 0. What about 5 pi over 4? Huh. 3 pi over 2? Oh, really? I'm going to put UND. Is that okay? That way it cleans up my table. You can't use not there, does not exist, or anything like that, because mathematically, when you have a 0 in the denominator, what is it? It's under 5. Okay. What's 7 pi over 4? All right. What is 2 pi? All right. Ladies and gentlemen, what happens at the undefined areas? Yeah, that graph. Mathematically, what has happened? What do we call those when we have undefined areas? Folks, we need to stop moving. Okay? What happens at places on the graph when it's undefined? What do we call that? No, that's not an irrational number. What does it create? What are those spaces on graphs? Could be a horizontal, could be a vertical, could be something. What is that called? You did them last year. They were named oblique, all that stuff. It's called asymptotes. Right? Asymptotes or basically lines that the function approaches, but never what? Because it's undefined there, right? So your work is to graph that, get it graphed, and then be ready, because tomorrow, well, if we haven't had a cut circle quiz yet, what do you think's going to happen tomorrow? Thank you.